Hi, this is Professor Sartor with another 10 questions from my college algebra class. This question says, use the substitution method or the elimination method to solve the following system. 7x minus 56y equals 28, negative 6x plus 48y equals negative 24. Now, I would use the elimination method in this problem, and that's because every term has a coefficient on it, meaning that if I were to use the substitution method and try to solve for those variables, solve for those x's or y's, I would have fractions on the other side. So I'm trying to avoid fractions in this question, and using the elimination method can do that. So I'll decide which variable I'm going to eliminate. I'm going to choose x to eliminate just because the numbers are a little bit smaller and easier to work with. So I need to find the least common multiple of the coefficients of x. I need the least common multiple of 6 and 7. And I can get that by just multiplying those two numbers together. And that's 42. So I need to force each one of these coefficients to be 42 and negative 42 so that when I add the equations together, it'll eliminate. I already have one of them being positive and one of them being negative, so I only have to worry about getting to the 42. So on the first equation, that's going to happen if I multiply every term by 6. And on the second equation, that'll happen if I multiply every term by 7. 6 times 7 is 42. 7 times negative 6 will be negative 42. And that's going to get the x term to eliminate. So let me adjust my equation by multiplying 6 times every term in the first equation. That would give me 42x minus 336y equals 168. On the second equation, I'm multiplying 7 times every term. That would give me a negative 42x plus 336y equals negative 168. Okay. Then you're going to add your equations together, and you notice how all of our x's are lined up, all of our y's are lined up, our constants are lined up, and most importantly, our equal sign is lined up. It's lined up so that we can make sure that we are combining like terms together. So when we combine the x's together, we're going to get 0. And that's what we planned. We planned to eliminate x. We add our y's together and we get 0 as well. We didn't plan for that. And 168 minus 168 is 0. So all of our variables eliminated, and that means that instead of getting an ordered pair, an xy solution for this question, for this system, we are going to be in one of the special cases. Now, the special cases are that you either have no solution or you have infinite solution. And you can tell which one of the special cases you're in by your final equation that you're left with. So let me simplify. 0 plus 0 is 0, and carry down that 0. My final equation is 0 equals 0, which is a true statement. That true statement tells me which one of the special cases we're in, and we're in the special case of having infinite solutions. It might be good to think of this as a picture. In the 3 cases that we have, these equations are straight lines, so I'm drawing straight lines. So you can have 2 straight lines that cross in a single point, and that's why some of the solutions give you an ordered pair solution. Now, Sometimes you can have two lines that are parallel to each other, which means they never cross, and that's when you get no solution. The one that we have is a case where the two lines are actually right on top of each other, and that means that every ordered pair that falls on those lines is a solution. So that's how we get the infinite solutions. Now, it's not any ordered pair because the ordered pairs that are not on the line are not solutions. It's only the ones that are on the line that are solutions. So we need to specify which ordered pairs are the solutions. So the way that we do that is we're going to take one of our equations. It doesn't matter which one. So I'll take the first equation, which is 7x minus 56y equals 28. I'm going to try to simplify it, and it looks like to me that all of these numbers are divisible by 7. So let me try to divide each term by 7. That gives me x minus 8y equals 4. And then I can solve for x. I'm choosing to solve for x because it doesn't have a coefficient. If y didn't have a coefficient, I would solve for y. Once again, I'm trying to avoid fractions. So I'm adding 8y to both sides, and I get that x equals 8y plus 4. So what we say is that my infinite solutions are going to follow a certain pattern. They're all going to be ordered pairs. My ordered pairs are x, y, but I'm going to take the x part and fill it in so that the x part is 8y plus 4, and the y part is just y. So we can find all of the ordered pairs that are solutions by following this pattern. Choose a value of y, it can be any number you want, and substitute it in, and you have an ordered pair that is a solution to the equation, to the system. Thank you for checking out my videos. Have a great day.